Hello and good morning, good afternoon, or good evening, depending on where you are. Can everybody hear me? Great, 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 great. Can you all see my screen as well? Should have the PowerPoint there. Perfect, perfect. Then we'll just wait, let's say 2 or 3 more minutes so we can get a few more people in there. You can already see that there's 2 questions open. One question from Purus Harf. I would recommend to send this question to our support team. So just send it to support@oneclicklca.com and give a link to your project, and we can check why it might be a certain value or not. So if you can forward that with a link to your project to support. I will indeed try to slow down a bit. I'll cover that in a second. Noel asked if the summer school license is available until the end of the optional presentations. They will be at least available to the end 3, to week 3, I mean. So after the optional ones also still. And we can look at potentially adding another additional week if you guys want to play around with One Click LCA more. That is possible. There's an anonymous question. How could we access the recording after the summer school for us to get back to? The recordings are sent every next day. Product LCA is unfortunately not covered in this specific summer school, but we have been thinking about perhaps doing a product LCA summer school as well, or might not be a summer school, maybe like fall school or winter school at some point in the future. I think we have a good amount of people here now, so we will get started. So today, again, if you have some questions, just put them in the Q&A part, and our moderators will be able to help them. I will try to talk for about 45 minutes first, and then we'll have a short break, 5-minute break, and then we'll go a bit more into the practicals of the software. So same like always, just try to keep your microphones muted. If you have some questions, use the Q&A parts. The slides have just been uploaded, but I'm not sure if they are shared already. I can see, can we still share them somehow? I'm not sure, but otherwise we'll share the slides after this session right away. In the last session, we kind of went over what is included in the summer school license. So we talked about what type of features there are, what tools. I gave a basic software training. So how do we access One-Click LCA itself? What is included? And you also had the code. Slide for session 4 not shared yet. Okay, apologies for that. We can try if we can share them later. They are already done at least. Feedback from the last session. So far, the feedback has been really great. We've had on average about 450 people attending each session. So that's really, really good number. And I think we can really teach some people how to do building LCA. I'll try to talk a bit slower. I actually have 2 screens set up now, so I can also see the chat. I couldn't see it yesterday. So if there's something that I'm going too fast, just let me know and I'll try to respond to that. We'll try to have a 5-minute break of after about 45 minutes, and then we'll continue with the other part. There were quite a lot of questions about the possibility to host the exam on another date or another time, because just not everybody can make it, because we are of course joining from all around the world. So we are currently looking into that. It will definitely be a possibility because of course we want as many people to have the option to pass the exam. So that is coming. Again, if you want to discuss the summer school with each other, or you want to connect to some of the people who are joining, just feel free to check out the LinkedIn LCA Made Easy user group, and we can accept you there right away. So today we'll talk shortly about the utilization of the carbon footprint in construction projects. We'll then talk about reducing emissions in practical projects. And we use an article from our website there called the 10 design commands for reducing emissions. I'll then actually talk about how we can do this in the project. So we'll have some data which we can upload later, which I will share. You can then apply these 10 design commandments, and it's actually also part of the homework. So part theory on how do we reduce these emissions, and then actually reducing the emissions in the project in one-click LCA. And then, of course, we'll shortly have that Q&A section like we had the last times. So in short, if we are looking at the carbon footprint of buildings, there are different types of building parts which will have different shares of emissions for the assessment. And this is the same for if we're doing a full LCA for an entire building, or if we're just doing a carbon study where we're only looking at global warming potential, for example. When we are looking at this example we see right here, it was a town center that was made, and we can see that the majority of the project itself here had a lot of structural emissions. So of course, the structure is usually the biggest part of emissions, but there can also be other parts of the buildings which can contribute to the emissions also. So when we are looking at the total carbon footprint, it of course depends what type of study we're trying to do. When we're doing this for certain certification purposes, perhaps like LEEDs, we're usually only doing the structure and the envelope. So we see in these examples, the finishes and the MEP, so the mechanical and electrical and whatnot, might actually not be included in those cases. But if we're truly looking at how to reduce it, we have to look at all these different elements. We cannot just look at the structure or just at the MEP or the finishes or whatnot. So everything in the entire building is pretty much important. When we are looking at total optimization of the carbon footprint and reducing embodied carbon, as we see in this example, we can first of all look at the structure. The structure is always the biggest part of the emissions. Doesn't really matter if we're doing a concrete structure or a steel structure or anything like this. And in the example, we can see here also that the base case, which we had here, cost 449 tons of embodied carbon. Then the as-built case, the case they actually ended up building, was quite a lot lower, 144 tons lower, 32% in reduction. The majority of the reduction here, they definitely got from the structural parts. So we saw that 252 tons were part of the structure, mostly from the concrete. And when they made some changes to, for example, include less concrete and start with engineered wood and these kind of things, they reduced the embodied carbon to 166 tons for the structure. So biggest saves were really made in the structural part there. When we then go further and we look at the building envelope, so the building envelope is often also required for most of these certifications. They managed to get some reductions, but the numbers were not that great. There wasn't like a crazy amount of reduction. They managed to reduce it, for example, with the insulation. They tried different type of insulation methods, which reduced the emissions by some. And then some cases, we, for example, had one type of insulation that was completely removed. It wasn't needed anymore. And of course, if we don't have to use materials, that is also great. When we then look at the finishes, this is usually an optional part. In, for example, BREEAM International, you can get more points if you report on the finishes, but in LEED, it's not needed. That can also have quite a big effect on the building itself. Of course, if we look at the totals, 449 tons, that we have 53% of these or 53 tons are part of the finishes. It's not that big. But as we can see here, by, for example, removing wood finishes or using salvage, so reused wood, the emissions were saved by quite a lot, so actually 43 tons less. Then building technology, or MEP, is kind of a more tricky thing. So this is one of the aspects which is sometimes quite difficult to reduce the emissions on, because these are part of the technology which have to be in the building. Like if we have a building, an office building with 6 floors, we have to have an elevator. There are different type of elevator manufacturers, but usually they all make the elevators quite similar. So those are emissions you're going to have anyway. We also have to have heating and cooling systems. Those are usually not that optimized to really have a better option from an environmental point of view, but usually more from a performance point of view, or they are bought from economic point of view because one manufacturer is cheaper than the other. So when we are trying to reduce MEP, or building technologies, we call it, there is not always as much saving we can do there, unfortunately. But still, over the entire life cycle stages, as we can see that for all the different type of materials we have here, it's still possible to get quite a lot of reduction by just looking at the different elements of the buildings. When we are doing carbon footprinting, so carbon studies or just life cycle assessments studies, we can of course do this from an environmental point of view for certifications. So depending on what we're trying to do, you can get different type of credits for doing different type of assessments. BREEAM, which will also be discussed during a later session in one of the optional ones, they, for example, have, first of all, the basics, where you just report on the mandatory parts. That can be just a carbon study, or it can be a full LCA study. And there we have, for example, the structure and the envelope, just like with LEED. But then they have the option to also give more points, depending on what type of other parts you include. So would you also include the finishes? Would you also include the MEP and these kind of things? You can have quite a lot more points-wise. With LEED, it's a bit of a different story because the scope of the materials is always the same, but there we have to really look at optimization, which is also something we'll discuss shortly today, but we'll also cover during the section 6. And of course, in this specific session on LEED, my colleague Joanna will also talk about LEED. I have already linked this slide before, but if you go to our website and you look for case studies, we'll have multiple case studies on different type of buildings, which have either used carbon footprint studies or they have used certification studies to really get good scores in different type of certifications. So they also talk about what kind of measures they have employed to actually get that. So if you are interested in that, definitely check that out. We also have some sections on experts who have used our software, and they usually also talk about a specific project they were specifically proud of because they have reduced the embodied carbon by X amount or they have achieved certain certifications. So definitely interesting to check out. When we're doing the carbon footprinting, we don't only have to do this for building LCA. We can also do this for different type of projects. So infrastructure is actually one of those. It is not really covered in the summer school here, but it's also important to know that we can apply the exact same principles there. So when we are doing infrastructure projects, we can also do this, for example, according to SQL. SQL is kind of the infrastructure scheme from the BRE. So they have an infrastructure scheme kind of similar to BREEAM, but really specific to infrastructure. We also have the PAS 2080, which you can also do for carbon studies, but you can also do it for a full LCA. For example, in the UK, they had the HS2 project, really big infrastructure project. They also did a full LCA on almost all the infrastructure they were delivering there. So carbon footprinting and doing full LCA studies are extremely important and are going to be much more relevant in the coming years as well. Then we'll go to the next point on today's agenda, and this is the reducing emissions in practical projects. So if you have already checked our website, you might have seen this article about the 10 design commandments. So that's the one we are going to be discussing today. In the 10 design commandments, we are basically discussing practical ways you can reduce the emissions, which you can apply to almost any project, regardless of if you're doing a building LCA study or if it's a carbon study or something similar. So we'll discuss those 10 options. There are, of course, many more options, but we'll discuss the ones you can actually make some progress with. And then I'll show you in the software how you can apply it to an existing design. The homework then will be part of this where you kind of have to do the same. So I hope you have already looked at the software a little bit because this will be, or that will have been already quite useful for the homework assignment of today. So reducing embodied carbon in our buildings is going to be very critical. I've already shared this, of course, during the first slide also, where we looked at the total global warming emissions. 39% globally is from the construction sector. Quite a lot of that is coming from the operational energy, of course, but that amount is going down. So at some point, the embodied carbon of our emissions is going to be the major key thing we have to focus on. There is still quite a lot of uncertainty on how we should reduce embodied carbon. I mean, I know it, my colleagues know it, of course, but if you're here, you're probably here to learn. So you want to know how you can do it yourself. We have this link here. You can also find it on our website. If you go to Embodied Carbon Reduction in Construction, it's also available under the resource pages on our website, where we basically discuss these 10 easy to follow design rules. We have, first of all, made a baseline building for this project. And it's also the baseline building that will be available for you to download later in an Excel format, and you can actually upload it. When we want to do this baseline, we were thinking, okay, we have to have something that you can see the difference quite easily when you make these kind of choices. In this case, we have chosen for a quite large building, 7,000 square meters. This building, or this fictional building we have chosen, has 7 above ground floors. It will be, each of them will be about 1,000 square meters. It will have 2 underground parking levels. The frame we have chosen for is precast concrete. Also one of the reasons, because you could optimize this really nicely if you, for example, choose a completely different frame structure. And the assessment period here would be 60 years. 60 years, if you have joined the other sessions, is a quite common assessment period. And if we basically follow this, it will be quite easy for us to do some optimization there. When we did all these optimizations and all these options we're soon going to be talking about, the total reductions on the building were about 33%. So that's quite good, but there were also a lot of more options you could still do savings for, of course. So the idea is that I will now discuss these options with you. Then we'll run through these options, and then you can see the final results next to each other and see how you can actually reduce the emissions quite easily in one-click LCA. So before we start, of course, with this assessment, there are a couple of things you might not have that much influence on. For example, if we're looking purely at reducing the embodied carbon, but somebody else already has done the energy model or the thermal model or whatnot, you might not have any influence on the energy performance. So the energy performance, of course, influences how much energy your building is going to be using, which can be quite important. If we are sourcing energy, it would be good to source this from low carbon energy suppliers. So maybe we're only doing renewable suppliers or anything like this. If you do that, that can, of course, over the entire life cycle of those 60 years, really reduce those emissions already. One of the things which you also cannot really include, or how do you say, influence in the design phase anymore, is where you're building it. That option might not be up to you. It might be up to whoever is commissioning this building to be built. If you're building it somewhere far away, where all the users who are going to be working in your building have to travel by car or by train or anywhere far away, that of course actually causes quite a lot of emissions from transport. So that is the B8 operational transport, which will also be discussed during the session on the 19th when we talk about the Norwegian scheme. So if we are building somewhere where people can easily get to work or easily get to the asset that you're building, in the long run, that can already cut quite a lot of emissions. And those kind of emissions, those savings, you don't really see in the building you're doing now. So if we're doing a building LCA carbon studies, that is not really represented, but it's still very important to know that this is an important aspect that you should be taking into consideration. For those with a little bit of interest in BREEAM you actually can get more points if you make the building in a place which is easily accessible, for example, by public transport. It's one credit in that scheme as well. Then I have here the 10 commandments we're basically going to be talking about. First of all, we have the first one here. It's designed for a use of multiple years or a multiple period. And the best period in this case would be the 60-year period. When we are looking at the 60-year period, it means that from the start, when we start to design the building, we have already taken into account that we're going to be using this building for a long time. And of course, if we want to use the building for a long time, it means that we have to have a proper building location. We have to have proper materials that will last longer, that we don't have to replace that often. So just doing that already can cut the emissions by about 40%. So that is not really something I will show now. We'll really focus more on the practical things we can do inside the software. But if you would make a design, you would upload some data there. You would set the period to 60 years, and you would make a copy of this. The second one, you set the period to, let's say, 40 years, like here. The emissions won't necessarily change, but the emissions per square meter per year, or just the emissions per year, they will be much, much higher if you have a shorter period of time, of course. So that is one thing which is very important. The second one, which you might not always be able to influence in the design period, but you can influence already far before in the strategy phase when they're deciding where are we actually going to be building, is building good soil conditions. So if we're in a location in the city where we don't have to put meters and meters of piling in the floor and pour concrete and steel and whatnot, we can already save the emissions by quite a lot. And versus the examples we had made, it's already about 30% you can save there. So very important. We then have low carbon structural materials. of course, quite common if we are using better quality materials or we're using materials which have been made in a more sustainable way. This can, of course, lead to quite a lot of savings. So a very important aspect there. The fourth one kind of targets or is intertwined with the low carbon structural materials is specify only sustainable products. While this is not always possible because sustainable products might not be available to you at any point, sourcing the best quality materials with the lowest environmental footprint can really save the emissions by about 10% at least. So depending on how tough you make the requirements on selecting materials, of course, it could be even a much bigger saving. The number 5 here is also quite common. Optimize your building shape. If you're having a project where some famous architect has designed a really cool looking building, it might actually take a lot of extra materials or very not sustainable materials to actually make it. So if we're building really simple, streamlined designs, we will have less need for materials. So actually it's quite common that you can reduce it in a good way then. Number 6 is reducing the floor slab size. If we are doing thinner floor slabs between buildings, and let's say we have a 7-story building, then we can save actually over about 6% of the emissions purely on the floor slabs. So very important if we're doing bigger structures. Number 7 is kind of a no-brainer. If we don't make parking structures, we don't have to use materials for them. So either we reduce the amount of parking structures, we make sure the building is like very well reachable by public transport. That can reduce by 5%, but if you're making massive parking structures, you can probably reduce it even by much more. So dependent on what we're doing really there. Number 8 would then be design for adaptability. If we can, how do you say, design the building in a way that we can also reuse it perhaps after 10 years in a different function. So we basically already consider the future. Is the company going to be changing? What are we going to be doing with this building? We could possibly already reduce some emissions there. So I'll talk about some examples there. Number 9 is something that architects maybe don't always like, is limit aesthetic features. So if we do not have to have a really fancy front with facade or really fancy bronze materials and whatnot, we can cut emissions. It's as simple as that. So buildings can also look nice without having a lot of fancy decoration, so to say, but it can cut, in our example, at least 4% of emissions. We then also have the number 10, choose long-lived roofing and windows. The roofing and the windows are parts of the buildings which are constantly battered by the elements. And those are elements, of course, or the elements basically cause them to wear much more often. Flooring is also one of those examples, but those things usually have to be replaced. So if you have a building, the windows probably don't last for 60 years. But if we invest in really robust roofing and robust windows, they might last longer than normally and don't have to be replaced as often. So yeah, those methods we have here, and specifically number 3 to 10 are the ones I'm also going to be showing in the example. And number 1 to 2, they are very important, of course, and there are some more important ones, but you cannot always show them in a life cycle assessment or carbon study. Numbers 3 to 10, however, together can already reduce the emissions by about 43%. So that's a massive thing, of course. And even if you don't have the option to implement all of these things in your building design, you will still reduce it quite a lot. So let's discuss these different elements and how this works in an example. So the command number 1 would be do not build for short term. If we make sure that all the buildings we are building will last for 60 years, they will never be empty, they will always be utilized, that's of course great. When we do a study for less than 60 years, unless it's perhaps a renovation study, this is not really worthwhile from an environmental point of view, but perhaps also not from an economic point of view. If there are changes in the city, perhaps what we were first doing was industry in one part of the city, but there are some new zoning laws, now it has to be residential, then it's possible that the building will be empty and not used at all. If we are having buildings where perhaps there is not enough transport nearby, that might work on short term, but in long term, the building could then also be empty. So short term, long term is very, very important there. When we are looking at long-term also, we have to look at materials that will actually last us longer. So the example you see here, if we have example 1, or we have a building where we actually design it from the beginning already, this is going to be an office for 60 years, regardless of what's going to happen, or at least people will be working in here for 60 years. We'll have the initial emissions, of course, for the manufacturing, so our A1 to A3. Those emissions or those materials will have to be brought to the construction site. So we'll have A4 emissions, of course, but then nothing really will happen. Let's say this was a building with really high quality materials, almost nothing has to be changed. So then there will be no replacements, but then of course, in the end of life, we'll have the demolition, we'll have the reprocessing, and we'll have the disposal of these materials. If this material only would last, let's say this building will only last for 40 years, or we're choosing materials which we have to replace at 40 years, then of course, the first 40 years, there's no difference whatsoever. But then at year 40, we'll have to have new materials brought in. These will have to be manufactured, of course. They will have to be transported to the site. The old materials will have to be moved away. And then still at the end, we of course also have those demolition materials. So we'll have much more materials which will process more emissions. And of course, it might actually also be more expensive if we have to buy new materials at 40 years in the future versus the ones we might already have in the building right now, because we cannot really predict the future in regards to material prices. So this one commandment, number 1, if we're just building for long-term in mind, so we don't even consider building for, let's say, a 25-year period or a 40-year period, we can get massive, massive savings. So we can also see if we have the normal service life we compare to here, so it was 60 years versus 40 years, we can already get a 40 to 50% reduction in emissions. But if we are limiting it, for example, to 25 years, the material emissions for a year, so year-on-year base annually, would be about 120% higher. So quite important, and probably the most important one we can have here. Then number 2, this would be avoid sites which require site stabilization or soil stabilization. So if we have to put a lot of structural materials, concrete, steel in the floor, of course, this requires a lot of emissions because they have to go there to make sure that the building stays there. When you start to build a building, and this is probably more for the strategy phase, there can already be tests done beforehand when they check for perhaps if the need for soil stabilization is there and whatnot. So perhaps if we are building on a marshy area, we might actually want to not do that, but build it on some kind of rocky area where the soil is much more stable. We actually have a tool in our software also called Site Designer, where you can do these kind of tests already. It's not included in this summer school, unfortunately, but it's something that you really can apply already before you're even thinking of building. So just building site-wise. It also sees here that if you're committed to certain sites, you can see how we can build it. For example, the distance to the bedrock, if there's any variations in the site, and then we can decide what kind of structure we want to look at. So it also says here, you could opt for a less heavy structural example like timber or timber or steel, and not use gas in place concrete, which is of course quite heavy in emissions. When we are reducing or when we are considering where we're going to be building, and perhaps we are not requiring as much site stabilization, so we're doing steel structure or timber structure instead of a concrete, we can already reduce it by about 30%. So that is quite a lot considering the entire emissions we have there. One note here also is that for all the commands we have used, we have taken the example of that our building would last 60 years. So just for demonstration purposes, it's easy to see. One of the third ones is considering structural options. So this kind of also links with the one before. If we are choosing for the foundation different type of structures, if we're using lighter structures, we'll have less emissions. Kind of makes sense, right? Less materials, less emissions. If we can use wood structures, of course, if it's possible, you cannot just build with wood everywhere, but nowadays there are much more projects like in Norway or in Finland where they're actually building high-rise buildings with wood. We can really impact our emissions because wood, of course, is a renewable material versus concrete or steel. When measured over the entire life cycle, if we're changing the structure of a 6 or 7 story building, we can reduce the emissions by at least 30%. So it is quite a significant example. We have here one example of a building which was made in Finland. If we are designing with wood here, we can see that A1 to A3 of our materials per square meter was quite a lot lower. And this was, in this case, an assessment they did over a 100-year period, which is quite common in Finland. There were also some other savings outside of course, the structural parts. So they also used wood-based insulation instead of mineral or plastic-based insulation. The outside of the building was wooden cladding. So we didn't have any fancy metal or bronze or anything which was high in emissions. And also all the wood, the doors and the window frames and whatnot, they were all wood. So no aluminum or anything like this. So based on what we have here, we can see that the construction phase emissions were quite the same. The replacement were also still quite the same because windows and doors still have to be replaced at certain points. But the initial emissions we had for building the project, they were much lower. So structural elements are very important in trying to reduce our emissions. As we see here, also kind of the same in the slide before, the reduction there would be about 30% if we're using lighter frames. There are nowadays also options for more like green steels, like Peco has this delta beam, which is much lower in emissions. So even with steel, you can get quite a low emission as well. When we have access to Carbon Designer in our software, Rosanna says that you're not speeding up today. Yes, I'm trying to talk at a bit more easy speed. We also have access to Carbon Designer in the software itself. So if you do want to make some optimization, you could, for example, take your building where you're currently living, put in those elements and make it concrete, and then compare it to the same building, but if it would be wood. And you can easily see that the reductions would be about 30% that way. Number 4 would be choosing low carbon products. So we have a massive amount of database in our software where you can really compare all the materials. But what kind of materials are we going to be buying for our products? So if you are the person who will be responsible for the purchasing or selecting the materials, you could try to, for example, take manufacturers who have EPDs. So who say that, okay, our product, let's say I have this concrete, it's much more sustainable than our competitors, and you can see it in our EPD because it's 30% lower in emissions. So environmental performance standards for materials are quite important. And it's also a really good way to reduce the emissions for the entire life cycle, depending on what type of materials we're looking for. We could also do this by, for example, carbon targets. And that's the number 2 here. So we could say that if we are looking for concrete, the emissions cannot be under or cannot be over, let's say, 250 kilogram per cubic meter or something like this. There are definitely options which would still be available for you. And if you, for example, have a concrete heavy building, which uses much more concrete, which has a high percentage of recycled binders or alternative binders or anything like this, it can reduce your emissions by quite a lot. This is, for example, very important where we have the type of materials where there is a lot of manufacturers for, and that the manufacturers are also really trying to do better. For example, on the field of concrete, you might have heard of Lafarge-Holcim. They're a pretty big concrete manufacturer. They're really trying to put out their green concretes and concretes which they are proud of because they have really reduced the emissions. There's also some case studies about that on our website if you want to check that out. So materials which are usually commonly available, like steel or concrete or even wood, there are quite a lot of options for that you can make a decision on actually making better choices there. I also put a small note here that tomorrow in session 5, our CEO, Panu Pasanen, he will talk about an overview of all the different types of construction materials and methods. So he will probably also discuss some of these and what you can find and how you can find them. And then during the session 6, which will be on Monday, and I'll host that one, we'll really look also into individual materials. So how do we compare these materials and how do we make sure that from the entire database of everything, we can basically find the best match for our project. What we can also do is look, as I also said, look at greener manufacturers. So try to find manufacturers of products which are really trying to make better products, not just trying to have an EPD for their products. This can, of course, be quite a common process nowadays, because how a manufacturer 10 years ago or 5 years ago would be manufacturing their product might be completely different from now. For example, there is this aluminum producer called Rusal. They have now launched an EPD for their aluminum products, which they have made with completely hydropower. So all the energy which goes into the manufacturing of their product is renewable, which will obviously lead to much, much lower emissions. We then also have here an example of some steel bar or rebar steel emissions from our software, which you can also access in the software if you're working on that. If you're then looking at different type of EPDs and perhaps what their kilograms of CO2 equivalent per kilo is, which is usually the functional unit for rebar steel, we can see that in the database, there will be much more different options. So the lowest option when we made this graph was a bit over 300 grams of kilogram CO2 equivalent per kilo, but then there of course also are much higher options. But I think that all the options we chose here were products which had at least 90% recycled content, so there can be still quite a bit of a difference. What we can also do is look at materials which are recycled or renewed. So if we are taking materials which have already been used, so perhaps they have had a previous life cycle, or they have a higher percentage of alternative binders, recycled binders, anything like this, they're automatically lower in emissions, or automatically in most cases. If we take the example here of concrete. Concrete is one of those material groups which usually has a lot of high emissions, and concrete is usually recorded per cubic meter. If we're then having the normal standard concrete, these are all concretes in this example with the same strength. So they could also be used for the same function, for example, for structural part of the building. If we have just virgin concrete, so no percentage of recycled cement at all, the emissions will be over 500 kilograms of CO2 equivalent per cubic meter, quite high. If we're then using a different type of alternative or recycled binder, in the second row here, we have 30% slag, which is a byproduct of making steel. We can see that the emissions are already reduced to under 400 kilograms of CO2 equivalent per cubic meter. If we're using fly ash, which is unfortunately not available everywhere, but it's usually also quite common substitute for cement, we can see that it also is still under 400. But then if we would use a combination of both, so we have 20% fly ash and 30% slag, the emissions would be just over 300 kilograms of CO2 equivalent per cubic meter. So depending on what type of materials we are looking for, all of these four concretes I have here, they could do the exact same function in our building, but some of them are just better from an environmental point of view because they're using recycled or renewable materials, byproducts, so that's very good. If we have two very easy examples here, if we have bricks, let's say we're building a brick building, can also still be quite common in some areas. If we're using normal bricks, which have been freshly baked, the emissions per kilogram of CO2 equivalent would be just under 250 grams. But if we're having bricks which we have reused, so let's say a nearby brick building has been just demolished, they have taken the bricks out carefully so we can actually reuse them again, they pretty much have no emissions. So the emissions would already have been accounted to the previous life cycle of our building, which basically means that we only have the emissions for taking them out of this building, putting them into our building again, putting mortar there, and that's pretty much it. If we're then taking a look at reinforcement steel, if we're building a concrete building, it always has to have reinforcement. Our buildings nowadays are not as strong during the Roman times anymore when they didn't use any rebar. Nowadays, they have to have rebar. If we have materials which are having 100% recycled content, even though 100% is technically not really attainable, usually 99% is the max, then we would have much, much lower emissions if we, for example, take the average of rebar products from Europe in our database. So if you're checking actually now in the software for reinforcement steel, you will find this option also from Norskstall, but there are also other options which have close to 100% recycled content versus completely virgin rebar or versus average numbers in Europe, they are much, much lower. So there are different type of things we can do. When we go then to bit kind of on the same story here, choosing low carbon products. So when we're choosing low carbon products, of course, it kind of depends on what kind of products we're trying to replace. In the examples of the structural materials, we can get quite high reductions, but for some materials, we can have quite some changes, like around 10% if we're making choices. In our database, we have over 100% different materials, or 100,000 different materials. It does depend on which tool you're using, because of course, as you recall in the second session, not all the data is available everywhere. Like in Europe, we're using CML data. In the summer school license you'll have access to CML data as well. But for example, in North America, they would have Tracy data. But there's still a lot of data there. Our clients that have an expert license, so the highest tier of our license, they can also add their own data, or they can make groups. And these kind of groups you can make yourself as well. And we'll also discuss that in a bit. Then, of course, the building shape. This is one which is quite straightforward. If we're doing a very simple shape of our building, we'll have less emissions because we don't need as much materials. So a very simple shape would be more material and energy efficient. When we are doing a certain size of a building, it might not always be possible to just do a nice square shape. Might be some daylight rules for that, or zoning, or other functional requirements, or as it says here, distribution requirements. So it's not always possible, but you can prevent of making really crazy shapes at least. When we do really complex type of buildings, so maybe some famous architect has designed it or something like this, this usually means that we need more materials. We might need very specialized or custom materials, which are higher in emissions. But it also might mean that we have to design the building in a different way, because otherwise people just cannot get into it, or they cannot get through it. So we might have to make different type of extra corridors there, things that otherwise might be office space, but now we have to put more walls, more windows, more doors, and whatnot. If we have a really oddly shaped building, we also might have to have more elevators, more staircases, more emergency exits. So we could actually have a lot of extra space we have to create to be able to get in or out of the building, where previously it could have just been office space. So we could have actually had people working there, but now most of the time it won't be used because we just have to have these elements in our building. When we are reducing the shape of our building, we can save about 10% of the emissions. It can be much more, but of course it also very much depends on the project. But if we're having a basic 3-story building where we have a quite basic streamlined shape, we can definitely have about this reduction. When you use Carbon Designer in our software, and this is something we'll cover more in session 6 on Monday, the building size there has kind of been assumed to be quite basic. So not exactly shoebox size, but not like crazy architectural designs, to ensure that you can just do these comparisons quite easily and see what we can get there. Then the number 6 would be designing thinner floor slabs. So the more floors of a building we have, the more floor slabs we will need, because of course people have to be able to work in the building, and it has to be structurally sound. Slabs are very important because they make up the structure and make sure that the building doesn't break if there's a minor earthquake or these kind of things. It's one of the biggest groups of emissions to the building next to the structure, or sometimes can be considered part of the structure also. And if we have more floor area, we need more slab space. So the bigger our building we have, the more floor slabs we have, basically. Slabs also have some functions. Aside of the obviously structural sound capacity, that making sure that we can work in our building, the building doesn't go down, it also has acoustic insulation. The slab is of a certain size, we might not hear the neighbors above or below us, so very good if we're working in a busy office. But it, for example, also provides fire resistance capabilities. It could also include the piping and whatnot. So the heating or ventilation system that we have in our building, we usually run through the slabs in the building, so we don't actually have to see it. So it can also have quite a lot of functional use. But if we're having a large building and we're reducing the thickness of the slabs for about 10 centimeters for every floor, let's say we have a 7% building, we can reduce the total emissions also by quite a lot. I think it's also about 10%, but I'll get to that in a bit. There are quite a lot of structural materials which focus on making sure that you can use less materials for slabs. And one of those examples here is the Delta Beam. It's one of our clients, Payco. They made a new green steel, which is much lower in emissions and can be used to make thinner floor slabs. And in their studies, it reduced the emissions by about 6%. So that was quite good. As we also see here, if we are shortening the spans for columns, for example, we could also use lighter and less cement intensive slabs. So the less cement or concrete we have to use, obviously the less emissions we get. It does say that it also has to be balanced against the impact it has on other materials, So we could not always do this perhaps, but in general, inputting thinner floor slabs in a building is a very positive development to reduce the emissions. I said it was about 10% reduction, but I guess it's about 6%. But it of course depends on your building as well. In our database itself, we also have a thing called constructions. So constructions are groups of materials, or you can also call them assemblies. And there's quite a lot of these ready-made available for use already. I'll show them also in a bit. So those you can use, you can basically check different type of options for the structural elements in the building. We also have a function called grouping materials, which also means that you can make these kind of constructions yourself if you want to do that. Commandment 7 is kind of a straightforward one. Do not build separate parking structures. Parking structures are usually concrete and steel. If we can avoid building them, we have less materials we need, less costs, less emissions. It kind of does depend where we are in a city. So where are we building? Do we have to have parking spaces nearby? But if we have built a building and we don't have to make a parking space, or perhaps we can do the parking space partially under the building, I'll show you in the next slide. It would of course reduce the emissions quite easily. What we can also do is raise the building a little bit so that we have the cars available under the building. And also if we have a kind of open parking underneath the building, we don't have to, for example, build external walls around this. So that again would reduce the emissions. One example I'll show you now is if we have a conventional office building. So let's say this is 7 floors or something like that. If we would have a parking space, perhaps it would have to be underground, and we would of course have to have materials to basically sustain this. If we are not having the conventional approach, so we just don't have any retaining walls, but we just put the office up a little bit, we can have the cars nicely underneath there. There can be airflow there, which is of course healthier also for the people who park there. But we also just need less materials. So it will be easier on the occupants of the material of the building and on the design process. So the parking or removing the need for actually making parking structures. In our study, it was about 4.8%. But if we are not making massive parking structures or whatnot, it technically could be much higher. So of course, it very much depends on what the need for parking structures is where you're doing your building. In Carbon Designer, as I also state right here, we also have the option to include underground parking floors. So if you want to play around with this, you could try to input an office building and then perhaps say, okay, first we have an office building without parking floors, and then we have an office building exactly the same design, but we add 2 underground parking floors. And you'll right away see that it will be higher in emissions, of course. Then the next one would be design for adaptability. So if we are looking at a 60-year period of our building, and we're perhaps thinking, okay, right now, the company is a certain size that we need 5 floors of office space, but perhaps later we need more. So perhaps the top 2 floors will be storage or whatnot, but later we can convert them to office space. If we already consider these kind of scenarios in the beginning, we can already start to plan for this. So we can perhaps use movable or refurbishable wall elements to kind of make sure that we'll always have enough room to do whatever we have to do in this building. Floor plans can, of course, change. So if we are using materials which we can easily remove, so perhaps we have glass walls between our offices instead of brick walls, or we have materials we can easily dismount, so kind of designed for disassembly principles also, it would really help us in, first of all, being able to redesign the office at a later stage. We perhaps don't need to buy new materials at that stage because we have materials we can reuse. And if we have materials we cannot reuse, we have to make sure that we input these in the beginning using design for disassembly, so we can easily remove them without harming or breaking the materials, and therefore making them actually recyclable later. We also have, what did I write here? Electrification, the track seating arrangement. Yeah, so one thing that you can also do, but this is more like building automation, it's not really related to perhaps building LCA, is that you can also have kind of systems which track occupancy. So if we're seeing that certain parts of the building are not used, they could be perhaps used for other things. But this is again kind of an extra step on what we're talking here. The last one, which I also said, is if you cannot really design your building to have elements of the building that we can change later, we can basically assign or for example, like CO2 sensors of building. So if we cannot really design the building so we can change it later, we should, instead of design for adaptability, apply the design for disassembly principles. One pretty cool example here is actually our office we have here in Helsinki. All the insulation panels we have put in the ceiling and whatnot, they are all entered with dismountable fasteners. So they're not glued in or whatnot. If we have to replace them at some point or the building will be demolished, we can just take them out without breaking them, and they can then be recycled. Not sure actually if these can be recycled, but at least they can be taken off quite easy. So design for adaptability and design for disassembly, which are also two principles which will be available in our building circularity tool. They are quite good to use. In the commandment 8, when we talked about these movable or refurbishable wall elements, the total emissions there in our case study would be about 4% saved. So they're of course not as big as, for example, changing a lighter structure or changing thinner floor slabs, but still everything helps. 4% on a total building is still quite a lot. In the software itself, when you're including materials, you can also change their service lives. So if we have materials which will last longer, or perhaps the end of life process there is reuse or recycle instead of disposing them, of course, this would be quite low in emissions. This could be low in emissions in making sure we don't have to get new materials later, or the end of life process, if we're reusing them, there would be pretty much no recycling or disposal emissions. So in different type of life cycle stages, we can get reduction in emissions using these principles. Then one thing, as I said earlier, something that architects might not always like, is try to avoid elements which have limited value. Like in a hotel, it might be kind of unavoidable because you need really fancy looking flooring, fancy looking ceilings and facades, because people have to feel welcome and feel like it has to be a really nice looking building. But these materials only have aesthetic functions. So not having them actually reduce the emissions by quite a lot. It can be about 4 or 5%. So if we have perhaps in our building internal ceilings, which actually have no function other than looking nice, so they have no acoustic properties, they have no fire protection or anything like this, we could just remove them, like from an environmental point of view, of course. If we're having less of these materials, which are kind of cluttering up our building, it would also be easier for those of the people who have to maintain our building or have to put in cabling and sensors and whatnot to actually do their jobs. So over the entire life cycle of our building, it can also have more functional use of not having these kind of elements. The same thing when we talk about the flooring, the facades and whatnot. If we're having a building where we just have, for example, a polished concrete floor, or you can use reclaimed materials like Kambi says. But if we're having like basic type of floor, which has no finishes, so no fancy layers, but just polished, it actually looks quite cool. There's a lot of offices nowadays who use just concrete polished floor instead of vinyl floor, so these kind of things. And honestly, I think it looks pretty cool. So you can have quite simple solutions using bare finishes, or as Kambi said, reclaimed materials, and it actually looks cool and it's lower in emissions. And when we take a look at the percentage of emissions we can save here, if we're only using reclaimed materials, it can be much bigger. But let's say we're just cutting out all those aesthetic elements that actually have no function. If we're removing the ceilings, we can remove about 1%, or remove the ceilings, remove the, the aesthetic elements for the ceilings. But if we clad it with, for example, just basic steel facing or whatnot, it can also be quite a much lower. And if we're applying this to the facade, the flooring and the ceilings, the reductions total can be about 4%. So from an environmental point of view, less materials is always better. In this case, it's a quite easy thing to achieve. Number 10 would then be choosing long-lived solutions for our windows and our roofing. If we have materials which don't have to be replaced as often, it means they will have less emissions, of course. If we don't have to replace the materials, they won't have to be reprocessed, they won't have to be disposed of, better from an economic point of view. And of course, if we're working in an office, which always is quite busy, let's say we have an office in New York City, right? It will always be very populated. There will always be a lot of people working there because it's prime real estate and everybody wants to work there. But if this office turns, let's say 30, and we have to remove or we have to replace all the insulation or we have to replace all the windows and whatnot, it's possible the building cannot be used for a month or so. And I'm not really sure how much rent an office building in New York costs, but it would be quite expensive. So it will also be much less disruptive for tenants. When we look at materials which are high quality, durable, and kind of work, we should try to pick those kind of things. Of course, it's not always possible everywhere in the world. So it does very much depend on where you are building, but usually you can find materials which have been manufactured, which are of higher quality, which just last longer. And then it could be that these materials which you're choosing are a bit more expensive to purchase in the beginning, but they will lead to lower cost in the long run, because you might not have to replace them. You might not have to shut the building down to replace them and all these kind of things. If we're implementing these kind of solutions where we're really trying to find better products that will last longer, specifically for the windows and the roofing, we can reduce the emissions by about 3%. So it does say also it very much depends on your project conditions. Like you might not be able to do this anywhere. It could have much higher emissions. It could also be a bit lower depending on where we are, but it would be usually around 3%. So these are the 10 commands that we described in our article. There are, of course, many more options to reduce the emissions in different type of ways, which we haven't really discussed here. One of the things would also be to implement those circular economy principles. So the design for disassembly and design for adaptability, they can, in theory, cause like a much bigger reduction. Buying local materials is one of those things we haven't really shown here, but if we don't have to ship or truck our materials in or anything like this, of course, we have less A4 emissions, less transport. In LEED, there's actually also credits for buying local materials. If you're building your building and you're sourcing all your materials from within 160 kilometers, you actually get points towards your LEED credits. And there are different types of credits for different schemes which have similar things. We also have to make sure that all the materials we use in our building have to be optimized for their function. So let's say if we have a building, we have a certain strength cast concrete. If we can go one strength class lower and it works, fine, we could do that. But we don't have to do the entire building with exactly the same concrete because it's easier. We have to really optimize every element of our building to ensure that we have the best materials there, basically. What we can also do is reducing waste. So we have different type of manufacturers. Just trying to think of which one is a good example right now. Forbo, for example, they make flooring. They have buyback programs. So basically, if you buy floors from them, then we can actually, let's say after 60 years, or no, not 60 years, my bad, after 30 years, if these have to be replaced, they will take them back for you. So they basically put the floors in your building. When they have to be replaced, they will come to you, they will take the floors with you, and they put new floors in. So you basically don't have to worry about any waste there because they take care of it. And they will actually recycle that floor also to be used in their new products. So there can be really good specifications for different type of materials that you're buying and what basically happens when these have to be shared. I think Elizabeth just shared a pretty interesting link from Unbuilder, so you can check that out as well. What we of course also have to do, the last thing is check how long we can use materials. If we have to replace it quite often, the emissions of course are much higher. So good quality materials basically solves a lot of issues. We also have another article which I won't really discuss today, but it's specifically for refurbishment projects. So we have created a kind of similar one, article which I just did, which talks about 10 ways of reducing emissions for low carbon refurbishment. So definitely check that one out if you want to find a bit more about this as well. Now we would actually go to this section where I show these kind of principles in the project itself, but I think we're probably at about, I went a bit over time, my bad. I would say let's have a 5-minute break now, because people were emailing me with the request if we can have a short break. So let's take a 5-minute break, and then we'll go to the project where we'll actually implement some of these things to the project. And I can see that Deirdre just told that interface carpets do the same. They do indeed, yeah. So I'll be back in 5 minutes. So take some water, take some coffee, and I'll talk to you in a second. Cheers. Alrighty. That was a 5-minute break. As you might have seen, I've also promoted our data manager to panelist again. I'm not sure if he accepted because I saw there was a quite data related questions. So maybe he can answer some of them as well. The tool is indeed cloud-based, so you don't have to download anything. So I will cut this PowerPoint for now. How do I end this? And let's go into the practical part of the session today. Let me just log in. Give me 1 second. So I have here a basic project, which I've already created with an Excel baseline, which you can upload later as well. I'm not really sure how I will get that to you, but I'm sure our marketing department will sort that out. Basically, you can just upload this Excel with the basic data there. So you just go through the import Excel, you select the files, you upload it, and you don't do anything else. I'll quickly run through this so you can again see how that goes. So I'll just say Excel upload. I'll just click on input data there. I again select this file. I have the file actually, where do I have it? Here, bill of materials. You don't have to do too much because this Excel, we have made it so it already has all the materials. So you can just click on continue, don't have to change anything here. The mapping here is already done based on the material names we have in the project. So you don't have to change anything here either. I just directly click on continue. It will then take us directly to the result page. And there are at least 2 parameters we still have to edit because we have to fill in also the floor area and the calculation period. I'm just waiting until it's done. Give me 1 second. So we can see here now, based on what we already have here, we have this. Can anybody share the sample Excel? Can one of my panelists come up with a good solution to share this file? I can share the file to them and they can try to see if we can share it. Give me 1 second. You can also do these practices that I'm doing now later, by the way. You don't have to do them while I'm doing the session because they're actually also the homework of today. I have shared the Excel file with my panelists. They can put it on Google Drive or WeTransfer or whatnot. You can probably access it in a bit. Okay, but yeah, we have uploaded the file. So then we have to make sure that we have at least assigned there the energy, the calculation period, and the building area. The building area for this template that I'm using was 7,500 square meters. So we have it here. I'll set the calculation period in this case to 60 years. So Samantha, one of the panelists, has just shared the file. So if you do want to already look at it, you can. I'll try to send it out also with the recording, by the way, when our marketing team sends that. So we set this to 60 years. For this example, I'm not looking at the energy consumption at all. So I will just fill in a value of 0. So it actually checks the box. Just give me 1 second. So I'll just set the quantity to 0. So we just get that green checkbox and it actually populates the data on our home. I think Samantha has seen the message. Probably she's trying to fix it right now. So if we go to the main part of the project, I should have 2 uploads now, which are identical because I've uploaded it twice. So this now has all the material data. So this is the baseline we have used for this 10 commandment study. If you open the materials query, which is where most of the emissions will come from, we'll have a lot of these grouped data. So these are the constructions or the assemblies or however you want to call them, which are basically set groups of materials which have a certain function in the building, which already have a calculation rule. So if we change what we have here, it automatically updates them and also changes the emissions. Of course, I have the settings now for Finland. So if you have different type of settings in your project, you might have a bit different emissions. But other than that, it should be fine. So now how do we optimize this? We have a lot of emissions here. So the baseline project is the one that I will keep the same. So we can see what we have done optimization wise. So then I will go into my second design and I'll actually call this, let's just say, optimization, so that we know what we're going to be changing here. And then perhaps the first thing we'll look at could be part of the foundation. And that is, of course, the soil stabilization. So I'm opening the building materials query, and we'll just try to go to the points we have here. So that one point I had before, the number one about building for short term, you can, of course, do this quite easy by just changing the calculation period. It won't really change the materials we have here, but the material emissions per year and per year per square meter, they will, of course, change quite a lot. In this example, we have the steel core piling. The steel core piling I have here, we can see it's actually 302 tons of emissions, so quite a lot. It actually makes up 14% of the entire building emissions. If we are using less steel or less concrete, and in this case, we have steel, which is 60% recycled, and we have concrete here, which is 10% recycled, we can already reduce these emissions by quite a bit. So I will now just search for this kind of construction. So I'll search for steel core piling. And we see that there is 14 of these constructions available already. Perhaps we could have built here actually on, let's say, 10 meter soil. So I have here an option for 10 meter. Do I actually have chosen hard soils? I have indeed. So if I'm choosing the exact same quantity, because these constructions are actually based on our gross floor area, and I'll just save it. We saw we had 302 tons if we have 15 meters. Well, imagine if you even have to have deeper foundation, let's say 30 meters, you'll have much more even. But if we're changing this to 10 meters, we should get a reduction probably already by about 10%, I would say. But we'll see in a second. Actually, it's much more than 10%. So it's actually 100 tons reduction by just removing 5 meters of the piling. So that is quite a bit. So I will just remove this one because I have now kind of optimized it. Then if we go to the other one, which would be structural options. So structural options, of course, affect quite a lot of the building. So we would have to perhaps look at the beams, the slabs, the columns, etc. But we can see what we can do here. So in this element, we have here concrete sandwich elements, and we have concrete columns. So perhaps from the concrete columns, if we're looking at this, we are having some 10% recycled binders concrete. So we could actually go for a better option, let's say 20% or 30%, which would already reduce our emissions. But we could also go for completely different type of columns. So the material filter up here, I'll set this one to constructions, and I'll actually choose here column construction. So I know that I'll have the right type of assemblies I'm looking for. If we're done having our options here, we see that we also have a timber column option. So the timber column option obviously will have different materials. This is one made from glulam. So if we're assuming that we have the same amount of columns, oh, I accidentally made a group up there, my bad. I'll just save it. I'll just have to wait until it stops making my group and saves. Saving is taking a bit longer than normal, but I guess we have a lot of users online right now. Just bear with me on this for now. So optimization will be a lot faster if you do it directly to Carbon Designer, by the way, but I will talk about that on the Monday session when we specifically talk about Carbon Designer. Okay, I think it has saved now. So if we then have those two column assemblies ready, these are kind of like simplified a bit because we're just looking at how much columns we need per linear meter. But we can see that for 605 meters of columns, if we are using a wooden resource, so glulam, we would have 41 cubic meters of glulam, which would lead to 5.9 tons of emissions. If we're doing the exact same thing with concrete, we can see that the emissions are quite a lot higher, 29 tons. And if we're also comparing these type of materials, so let's say we take the concrete, the steel, and the glulam next to each other, we can see the emissions are much lower for wood. So we have here the emissions per kilo for glulam would be 28. Of course, we need less wood because it has different density than, for example, the concrete. But if we need concrete, we also have to add rebar. So that then again adds up. And if you're not really sure about these kind of densities, you can usually also open the technical characteristics. So here it actually says that if we are having wood, we have about 500 kilograms of wood material per cubic meters. But if we have concrete, we'll have 400 kilograms per cubic meters, plus there is also, of course, rebar steel, which has to go there. So depending on the type of materials we're choosing, and wood actually would be a better option because it's even renewable. So we can also incinerate it later, for example. The emissions can already be reduced by quite a bit. So this is just one part of the elements which I have now replaced. But if you would go to all of the different structural elements in our building, so not only the columns, but perhaps also the beams, etc., you can get quite a lot of much lower emissions. So if we are checking here, the roof assembly for our building here in this example is also concrete. We have then also concrete ground slabs. We have concrete beams. Replacing all of those will really reduce our emissions. So I'll just go now to my beam constructions, and I'll also replace the concrete beam. So I'll just take a timber option there also. I'll enter the same quantity. Maybe I can also change my ground slab assembly. Let's see if we have also timber there. It seems we might have called it differently. Not sure if we actually have some option right here. We could pick, okay, maybe I don't change this right now. I'll just save this and let's already do a comparison. Susanna asks if we can show again how you can get started in one-click LCA, download the Excel and end up on the page that we're looking at. Well, we have to wait until this is saved anyway, so I can just open this. First of all, you of course have to go to the one-click LCA website. So just our main website. We can then go to login there. You have to have an account, of course, but if you don't, if you have already registered your account, it will allow you to log in right away. So then we basically have it here. You have to then start a new project. I think my thing is still saving, so it's fine. And the summer school key to access the project or to activate your project works with a license key. If you check the slides for session 2 or session 3, it will tell you already how you can access it. Session 3, my bad. So if you would fill in LCA Summer School 2021, which is the license key, it activates the project to this license. So then we just make a project name. So this is my new project. I select whatever I want to do. Perhaps I select that this is in Finland. I can already fill in some information, but it's not needed right now. We select up the first design. So you just click here on Get Started. We have the different tools we want to do. So I'll just add all of these right now because it displays quite easy. We have to set up our new design. So if you're starting this from what I was doing, just maybe perhaps baseline, because that's the one we're trying to improve. And then you can, of course, also go to the settings to make sure that it's relevant for your country or where you are doing the assessment. I'll just use the default setting here. You then go to input data, where you can also, of course, do all these manual inputs, but you can also there go to import Excel, and you just run through the file that Samantha shared earlier. And if you have done that correctly, you'll end up with what we have here. So if I now have changed just the two things, we looked at different type of foundations for our building. So we reduced the amount of piling needed, and we changed some materials from our structure. We changed it from concrete to wood. We can already see we have already achieved an optimization right here. So if we're comparing them, it's already about 14% lower. If I would now go to my result page, maybe I'll take the levels one in this case. And I'll open the total results. I'll click here on compare design, and I want to select this again, or I want to compare it against my baseline. So I want to see what we have already done here. I can see then from just the changes, from a global warming point of view, we have already reduced 14%. So of course, that doesn't yet come close to that 40% reduction, which I said if you do all these different elements, but it's already quite a big step. So reducing certain elements or certain materials, using less materials will already change it quite a bit. We can see here that the biogenic carbon went up, but of course, as you recall from the second session, that's not a bad thing. So that's the amount of carbon stored in our organic materials. When we are doing this also for lead later in the session 13 or 12, I'm not really sure. Joanna will also tell you about this comparison more because it's really important for lead. So let's do two more changes at least, and then I can probably answer some questions. So I will continue with my optimization one, because that's the one I still want to compare it to, of course. So we'll open this one. We open our building materials. And perhaps let's try to find some low carbon products. So let's see what we have here. We have here some carpet. Carpet can be quite high in emissions. We can see that we have a lot of carpet in this building, which is actually 213 tons of emissions. So if I open this one, perhaps it can already give me an idea of why it's so emission heavy. And this is probably not the best carpet I can use. So I have, of course, nothing against a specific manufacturer, but we can probably find a better option for this. I can also do the C-full ranking, but this I'll cover a bit more also in the session 6, and perhaps Panna will cover it also a bit more tomorrow. But let's try to at least replace this carpet for an option which is lower in emissions, potentially one which lasts longer. One of the reasons also why this carpet is so high in emissions, if you see here, it's also because the service life of this carpet is 15 years. So this one actually doesn't last you as long. So we can see that the initial emissions are 33 tons, but then we have 155 tons of replacement emissions, which are of course coming from the materials which have to be replaced, the transport, and also the end of life of these. So I will go to change. I'll click on the replace button. And let's try to find a better option. Do I want to take a carpet or do I want to take something else? If I go to flooring, I can see what other options we have there. Maybe I'm not that biased by what kind of flooring I want. I just want something that's good. So I'll leave it to flooring, and I'll set the CO2 filter to very low. So I only get the top 20 best performing flooring materials. Maybe I'm kind of biased and I want to search for a Finnish manufacturer. So I know that we have something better, but there is none. Okay, I cannot get really good flooring in Finland with an EPD. That is unfortunate. Then maybe there should be something in Norway, I would say. And there is indeed two options. We have some options here, which are high pressure laminate flooring. Well, I could do a laminate floor. That might not be so bad. If I select this option here and I check the environmental profile, I can see that this one is quite a lot lower. So if we're perhaps looking at square meters, this one is 3.5 kilograms versus 9.08. So, okay, well, the Finnish option wasn't there, but we have a Norwegian manufacturer who can help us out. So we change our flooring to the nice laminate flooring, and that should reduce the emissions at least by half. But let's see. Laminate might also last a bit longer than our carpet flooring, so it can also lead to lower replacements, of course. Just have to wait until it goes through. So we have our flooring, which is now changed, and it actually went to 102 tons of emissions. So that's quite good. So that is one thing we can do with these kind of low carbon products. So we can try to find the best options from the database. Of course, they might have to be available to us. Like we cannot just say, okay, we're gonna get this product from that country, that product from that country. So local materials are important. But if we can find options which are lower in emissions, that is of course always great. Thinner floor slabs we can do, separate parking structure we can do. Maybe we can try to include some reclaimed elements. We have, for example, some roofing tiles here. The roofing tiles are not that high in emissions, just 7 tons in this case. But what if we have actually gotten these salvage materials? So we got them from another building. What we can then do is we just check that reuse material box. So for reuse materials, there are often no EPDs. It's not as interesting for a manufacturer to pay, let's say, 10,000 euros to create an EPD for already a reclaimed material. But we have this reuse material option, which can lower the emissions quite a bit. So if I just make a copy of this resource, so I can show you what the difference is. So one of them I'll set to reuse, and one of them will just be normal material. I'll just save. And let's see what kind of results we get from this. I'll just have to change this for a bit. Tunde asks, what is the local compensation accounted for in? I would recommend to check the article we have on that. So if you're in the Help Center, just go to localization, and it will tell you what we include in that. But basically, it looks at the emissions for production in one country, how much emissions are, or how much energy is needed for production, and then also it looks at different material types. If I now try to find my nice concrete tiles, I can see if we are just buying these concrete tiles, then we would have emissions per, what is it, square meter that we do of about 11 kilos. So then for 875 square meters, we'll have 6.8 tons of material emissions. We have some transport of this, and of course we have some end of life. If these are concrete tiles which are reclaimed, we basically don't have those production emissions. So if I open it, no A1 to A3 emissions, we have same amount of transport still and the same amount of end of life, because these materials will still have to be replaced, of course. And since concrete tiles will pretty much last the entire life of the building, they won't have to be replaced either. So we can save, let's say, about 7 tons of emissions there. So if we're using reclaimed materials in the assessment, for something like this, the effect might not be too high, but we can reduce the emissions by quite a bit. So let's try to at least find one more option to do. In this example, I don't think I really had a lot of, how do you say, aesthetic elements, but what we could, of course, also do is we just remove the parquet flooring or something, and we use a polished concrete. Maybe we can try to find something which is very high in emissions and see if we can replace it. We have some triple glazed windows. If I'm building in Finland, where we get in the winter to about -20, I cannot really change this to, for example, double glaze, like we'll freeze in our office. So we cannot do that. But is there anything else we can change here? Quite good. We could indeed change something in the hollow core slab. That is for sure true. So hollow core slabs, we can, of course, reduce the thickness of our slabs. So if we reduce these slabs by, let's say, 10 centimeters for everything, let's see what we get there. We right now had it there. I'll just save. Now let's see what we get for reduction by just changing these slabs. Give me 1 second. Zahabi asks, how is the impact for a reused material calculated? Is it possible to see the input and output of a reused material? Basically, the system we have implemented is quite simple. You just don't have A1 to A3 and A5 emissions if you check this box. So it just takes those apart. You still have the mass of the material. So the mass of the material will still have to be transported to where we go. And of course, it will still have to be recycled also on the end of life. But it will just not have A1 to A3. If it's a material which is sourced locally on site, so perhaps it was already present there, or we have reused the structure of a building and we build on top of this, then of course you wouldn't have any transport emissions either. So then in practice, you would just have the end of life. So by just changing this hollow core slab, we actually removed about 18,000 kilos, so 18 tons of emissions. Not a really big change I did there for that, but we can see that the change is quite good. If I would now go back to the main page, I would just compare these two again. Let's see what kind of reduction we got there. First, yeah, fair. I indeed reduced it in millimeters, not in centimeters. That is probably the reason why we didn't get the 40% reduction, but the bit under 1% reduction. Good call, Chaza. If I now go back to the result page, and I've just taken the carbon one now, doesn't really matter which one I compare, of course. We can see we now already are at a 20% reduction. So that is already an improvement from the 14% on. So these kind of changes, which I had discussed earlier, which you kind of should be doing for the homework assignment today also, is just upload this file that Samantha shared. It will also be shown later. And then try to do these kind of reductions. So go into these materials, change them to better options, change them to low concrete options, change the structure from concrete to steel or to timber, and just try to see what you can get, basically. So there is a lot of options we can do there. Yeah, that was pretty much it for what I was trying to teach you today. So really about how can we reduce the embodied carbon in our buildings by changing certain elements or changing certain materials. And then you can, of course, upload that and make these kind of changes yourself. If you then also want to compare them, you can also see them quite nicely like that. Maybe I'll set this one to the global warming potential of the levels tool, so you can see a bit more also, and the different type of indicators of these kind of changes. Yeah, then I will share my PowerPoint again. Give me 1 second. And I shared the wrong slide, my bad. So the homework for today, for session 4, will basically be upload that bill of materials, the same one which I have used, and then go through everything you have in those 10 commands we had today, and try to reduce the embodied carbon of your building. So I think it should be quite straightforward. Also try to see if we can also share this bill of materials when we send out the recording. If there are then some questions, I can try to answer them now. I'm checking if I can actually save, or how do you say, share my Q&A part also. Let's see. Do you guys see the Q&A on my screen right now? Okay, you cannot. Huh. Yeah, Zoom is sometimes very interesting in how it works. I'm not really sure why it doesn't share that. Why does it do this? Okay, I will set it to the homework screen indeed. So give me 1 second. And then I can try to answer some questions, and I'll try to just answer them out loud. So can you see the homework now? Yes, we can. Okay, great. So I see my panelists have already answered some questions. One of the anonymous attendees asked, what does this 3+1 points mean? I assume you're meaning the credit you saw on the lead page, which is basically credits you can get for different type of things. So when we do, for example, BREEAM, if you do the minimal amount of points for a normal life cycle assessment, you can, for example, get 3 credits. But if you do more, so you include building elements which are not mandatory, you can get more points for that. There is one question here from an anonymous attendee. What are the criteria for choosing a baseline building to assess durability in a building? The criteria depend on the type of certification you're doing and where you are building, but normally a baseline building would have materials which are typical for construction in your area. So if there's a certain way that they are building offices in your area, try to use materials which are common for that, and then you have to improve based on that. So yeah, there's not really a good standard for that, but it's usually typical materials, and then your actual building that you're going to be building, of course, you want to have that as accurate as possible. There's an anonymous question which says, what would be the example of a long life window? I typically use 30-year replacement cycles. Would it be higher than this? 30 years is already kind of on the high side, but there are some better options also available. I'm not sure what the highest life cycle of a window is. I'm unfortunately not a window expert. But if you want to try a check in our software, you could see what the different EPDs state. Because if you have an EPD for a window from a manufacturer, they will tell you how long they expect that their product will last you. So it might be longer. But of course, windows can be a bit tricky, because if you have a window which is in -30 in Finland, or you use this in Spain in the middle of the summer, they will not last as long, of course. There's an anonymous question here which says, which one is good for planning? Building with the longest lifespan of durability or shorter? Some places have a policy for demolition for particular years. Very much depends on the zoning requirements of the city or location you're building. Personally, I would build for long term, so durability. Usually also it's a more economic option of building. Rosanna asks, is a 60-year minimum desirable lifespan? Depends on the country. For example, in Finland, I think we build for a bit longer periods of time, so not really 60, but more like 80 or 100, even for residential buildings. So depends, but 60 is kind of the generally accepted minimum standard. So in Leeds International and Bremen International, we do 60 year usually. Anonymous attendee asks why no A5 installation and assembly. Well, I just didn't include it in this assessment. But of course, you can also get reduction in A5. Definitely possible. Fab asks, does the comparisons between timber and concrete construction account for biogenic carbon? So biogenic carbon, as I explained earlier in a different session also, under the current EN 15804A1, it's only displayed as stored. So it is not included to the totals, but it's basically up to you what you do with this information. Under the A2 scheme, it might become different. But basically, concrete, it doesn't automatically count for concrete carbonization, but if you have any organic materials, it does list the biogenic content. An anonymous attendee asks if would sandwheel panish construction be better in terms of emissions and also in terms of efficiency? It is possible. It depends on what you're trying to build, of course, what kind of building. Tejas asks, what about the environmental impact due to deforestation or timber farming? So that is something you don't necessarily look at in the current building LCA, but for example, in the Norwegian scheme, we are considering also the global warming potential for land use and land use change. That also includes the environmental impact of deforestation. Under the 15804A2 scheme, land use and land use change global warming potential is actually an additional indicator. So I assume it will become more relevant and more important in the near future, but it isn't really considered in LCA right now. So it will happen. Daria asks, can you spell the name of the green concrete manufacturer? I'm not really sure which one I showed anymore. I'm not sure if anybody else remembers. And Daria also asked, and the aluminum producer, is it Rusal? It is indeed Rusal. Ante just thought LafargeHolcim, indeed. They make very nice green concretes with our software. And aluminum producer, it's indeed Rusal. I think both Rusal and LafargeHolcim have a case study on our website, so you can check them out. An anonymous attendee asked that in Asia, the concrete is the material of choice. We have very few hybrid frames or for faster construction. Indeed, Asia is one of those things which is kind of tricky because LCA is not as important there yet. So they are not really doing this kind of optimization yet. But I assume it will change in the future. I just have no idea when. Like building LCA and carbon studies are definitely more done in Europe and in Australia and in North America, but it is upcoming in Asia for sure. We have a lot of Asian clients who are doing this and who are perhaps the first ones in their countries who are doing these kind of things. Abdullah asked, I am not sure if these different concrete mixes are the same. I remember there were some difference in durability and other aspects when adding ash or slag. Yeah, so basically if you're looking for concrete, you're looking at the filter settings, I would first select that you're looking for the same type of concrete. So if we're doing concrete for external walls, you select just those type of concretes, for example. In the material names, you can usually already see why there is a difference. So a manufacturer might say, okay, this has 50% fly ash, this has 40% fly ash and whatnot. Technically, if the materials there are set to have a certain strength rating, so let's say C25, C30, 4,500 to 5,000 PSI, it doesn't really matter what the content of the fly ash is or whatnot, because they all have the same strength rating, so they could all be used for the same purpose. Ani just shared two interesting links, one for Rusal, and I guess, oh, no, that's the one for Rusal, about low carbon aluminum. An anonymous attendee asked, in terms of reclaimed materials in a practical sense, how do you come across these materials? Which party is responsible for saving these materials? Very much depends on where you are. In Finland, there is this company, I just lost the name. What were they called again? Antti, do you remember maybe? There's a company which basically gets reclaimed materials or waste materials from building sites and resells them. In Norway, you have a company called Loopfront. They have basically a platform where anybody can get reclaimed or salvaged materials. So usually there is some kind of local partner, but I'm definitely not aware of all these local partners in all countries. And it's definitely something which is not done in every country either, even though it probably should be needed. Rosanna asks, is there a certification that classify or identify the greener manufacturers and choose the one with environmental approaches in industry or process? If it does it give a point to a green certificate? So in BREEAM International, you can get credits for choosing manufacturers who have certain certificates, for example, for sustainable sourcing of their materials, but this is usually not data which you see in the EPD itself, unfortunately. So this is something you can do outside of the EPD assessment or outside of the building LCA assessment. Ina asked, are all other qualities for the concrete types they're all the same? Not exactly, but if you're searching for certain concretes and you're searching for the same strength class, it means that in theory, they could all be used for that specific function. So of course, if you're building a building and you know that you have to have a certain strength class concrete, let's say in Finland, we're doing external walls. Yeah, it might be that one. Abdullah, thanks. Not sure if it's that one though. Could be. Netlet, indeed. That's the one that Ani just linked actually. But yeah, when we talk about concrete, we of course have to take the materials which make sure that the building can be structurally sound and can actually be what we intended for. So you, for example, you cannot reduce the emissions by taking a weaker concrete. Like, I mean, you can in your calculation, but it would be false. Like, it would not be true. So don't do that. Dieter asks, how is recycled rebar used? Is it melted down and remanufactured? Is it known prior to the reuse of rebar specifications? Rebar is usually melted down and remanufactured as rebar, but rebar can always be reused pretty much. So there is a lot of let's say 99% rebar percentage available. Tanya asked, does applying so much wood in building construction in order to reduce environmental impacts risk a fire risk? Is there any limit in fire protection rules regarding this? It depends. You can impregnate woods to the same extent that it pretty much is as fire protective as concrete. So it doesn't really matter. I think wood construction is one of those things which can be a very major benefit to our society because the emissions are so much lower, but it's usually something which could be frowned upon still. In Norway, there's this really cool project. I think it's called Mjolstornet or something like this, which was the highest residential completely wooden building, which is pretty much as safe as a normal building. I mean, if there's a fire in a 70-story building, probably you don't want to be stuck on top, regardless if it's concrete or wood. So. Ronnie asked, the slides of today's webinar are not mailed to us yet. Yeah, we'll try to get them to you after this because I actually was a bit late with finishing them. So I think Ani did share, or Samantha did share the slides in the beginning. So if anybody wants to put them there again, we could do that, I guess. An anonymous attendee asks, how should we evaluate the building renovation project when the main structure is maintained? Should we totally include the existing structure in the LCA, or should we consider them according to the building age? Let me just send the link for the slides. Give me 1 second. Not shared yet. Yes, I know this now. I will share it with my team, and if they can somehow make sure it's shared, I'm not even sure if this is a shareable link. If you guys can check, you can probably see it there. All righty. Back to this. So if you're doing renovation, you can kind of decide yourself what is the best way to do it. What I would recommend to do it is you still include the materials which would already be present, because these might still have to be maintained. They might still have to be replaced because perhaps they have been functioning for 60 years, but can only function for, let's say, another 40 years. So if you actually use that reclaim material option in our software, it reduces the A1 to A3 and the A5. But you'll still have the replacement and the end of life emissions. And of course, those you want attributed to your building for accuracy stage. In some cases, people just leave them out completely. Like if they're completely reclaimed materials, you could argue that they have no emissions, but there would always be some kind of transport emissions and end of life emissions. So it depends on how accurate you want to be with your assessments. Deidre asks, does the reduction in embodied carbon and building materials cost increase in cost as more specialized ingredients are being used in materials? Not necessarily, but it very much depends on the product. Like they could be finding some alternative binders. Like I know that there are some companies who are currently developing concrete with rice husks instead of fly ash. Well, I mean, I'm no expert on rice farming, but sounds like it probably could be cheaper. An anonymous attendee asked, does thinner floor slab, or is it safe from earthquakes? That is a good question. If you're building in an earthquake zone, you will have to have a thicker structure anyway. Like the structure cannot be the same as if I would build here in Finland, for example. So I don't want to give you wrong advice, so I'm not 100% sure. But of course, the building always has to be structurally sound. So basically, if you're designing the structure and it has to be safe for, it has to be like earthquake proof, it might not be an option. Like you might have to get your reduction somewhere else. Harry Fry asks, typically, is it better to have parking structures external to the building rather than indoors? Typically, it's better not to have parking structures. Less materials is better, of course. But depends, like less materials, the better. If you can somehow have it inside the building, so underneath the building, like on the first floor or whatnot, with open space, you'll have less materials and you'll have lower emissions. Might be better to have it external versus doing it completely underground, but it very much depends on the purpose of why you need the parking structures. So less parking structures, better emissions, basically. Rosanna asks, optimizing the building shape can be a more smart logistic to design rather than a creative facade. Yeah, it can be indeed. You can also make really cool building shapes which are low in emissions because they don't have weird facades. So it's possible. Rosanna asks, not separated parking lots can help the LCA, but influence the life cycle costing since less floor is less profitability. Yes, possibly. But I mean, if you're having an office building and you're building the parking space so that your people can work there, I guess it doesn't really matter that much. Of course, if you're like a developer who owns parking structures, that's your way of making money, you probably want bigger parking structures. An anonymous attendee asked the potential savings. How are the percentage of savings arrived? Is it arrived from real data? In this case, the data I had in the case study, which I used here, it was from Carbon Designer. So we have basically inputted the parameters of a certain building and then just compare the materials between them. So the quantities we have there are kind of like real simulated data. But there are definitely a lot of these studies which have done these calculations. So they are grounded in definitely truth. Hashem asks, it has already been mentioned repeatedly to maximize the usage of the building. Is there a direct relation of having more occupancy of a building with reduced embodied carbon? If yes, is it quantifiable? I mean, if you're, let's say I'm having a building which allows 100 people to work. If they're working for me, I'm making money. If I only have 50 people working there at any time, I'm making 50% less money. So if I only have 50 people, why would I build for 100 people? So then I have, of course, lower emissions, definitely. It very much depends on why you're having the building and whatnot. It's like, it can also be a very theological question. Anonymous attendee asks, can you give examples of long-lived materials for windows and doors that you mean here? If you, for example, have windows, if you use wood versus aluminum or PVC frames, your PVC and aluminum frames will last longer, so they don't have to be replaced, for example. If you have doors, wooden doors that eventually rot, let's say after 30 or 40 years, if you would have a steel door, this will last you whenever, like. There's a lot of questions, guys. I'm just trying to answer them, but there's quite a lot. Abdullah asks, isn't a standalone software better than cloud-based? I'm wondering if One-Click LCA didn't consider that. We definitely did consider it, but cloud-based softwares can be accessed anywhere at any time. So if you want to do an LCA on your computer or your tablet or your phone, you can access our software. You don't have to go through your IT department, try to get everything installed and try to do difficult stuff. I mean, we definitely like cloud-based much better. But yeah, it's also kind of preference, I guess. Mitya Hokanen asks, can this data be viewed as an example of a real building? What kind of? I kind of lack a reference building LCA that makes sense. Carbon Designer is based on real buildings. So Carbon Designer, the tool which I also use to generate this bill of materials, it was originally made for the Norwegian real estate organization Stadsbygg, And the values we have there are all based on case studies they have done on actual buildings. So it is as pretty much as accurate as the tool can get for early phase design. So definitely use it like it could be a real building. After the summer, we're actually launching a new iteration of Carbon Designer. Which will have a majorly overhauled structural elements, so it also can fit larger buildings, higher buildings, basically. So yeah, it's based off real buildings, but of course, you cannot always have everything accurate. Dieter asks, when optimizing materials by using recycled materials, can this affect the structural design dimensions, for example, the columns? It could, I guess. Kind of depends. Like if I have columns which have virgin concrete, or I have concrete which is 50% recycled because of fly ash and whatnot, it doesn't really have to change the density. So it doesn't really have to change the dimensions necessarily. It very much depends on the product. Like, doesn't have to affect it at all. An anonymous attendee asked, for Asia electricity, it doesn't take a default. What default should we feed? If you put your project to your location, there should be at least a profile, because we have profile data for pretty much all countries. So you can check that out. Anna just shared a really cool project from Canada as well, if you want to take a look at that. An anonymous attendee is asking why the rows for use phase and repair rate are blank, as well as the energy use, because I just haven't filled them in. I mean, you can get reductions on all the life cycle stages, but today we're really talking about the building materials and how we can reduce these and how we can get the reduction there. Energy, let's say in 30, 40 years, probably is going to be completely renewable. So you cannot really get any reduction there anymore at that point. But building materials is the point we can get a lot of reduction still. So that's what we're trying to focus on here. An anonymous attendee asked, could you explain the concept of carbon stored by materials? I can, but I would also recommend you to check the biogenic carbon article. So basically, if we have organic materials, which start, let's say a tree started growing, right? It absorbs already carbon dioxide. And it keeps this until you burn it, when it releases it back into the atmosphere. So if we're having a building which is completely made of wood, it will store carbon, which basically is not expelled in the atmosphere at that point. So, but yeah, check the biogenic carbon article if you want to explain, if you want to check that further. Are there auto-finding ways for getting the best product with minimized carbon emissions in the tool, or do we find them manually? I'll discuss that more a bit on the Monday session, but if you have done your assessment, maybe I can just quickly share the screen again. And if we are on the result page, you have the option to also look at those top 25 most contributing materials, if you can see them right now. And you can there just click, for example, on show sustainable alternatives, and it right away finds some better options which are relevant for your location, which you could be using. And of course, you can also use those filter settings to search for like lower emissions. So there is definitely some options to help you there. Juliana asked, in this example, when you select the flooring from Norway, does the tool already take the transport emissions into consideration? No, it does not. So we have this localization mechanic, which I said earlier, which basically accounts for if you take data from outside of the country, that it adjusts these emissions. So if you still want to include that these materials are actually imported, you will have to manually change the transport distance. So that is something we don't always do. I see that some people have to go, so thank you very much for joining. See you in the session tomorrow at least. Ravi asked, changing the country of carpets, does the local automatically accounted, the local compensation? Yes, if we take data from another country, it automatically kicks in that local compensation mechanic. Already answered 86 questions, but there's still quite a lot open, so I'll just keep answering some of them. Marina asked, can the cost be compared somehow the same? Yeah, you can do it exactly the same as we do it with a lifecycle costing tool. We just haven't included it to this summer school. Perhaps we do that in a different session, it's possible. So you can do exactly the same comparison as we do here. Santiago asked, in some countries, we have to import windows and roofing, which will improve internal efficiency of operational phases. So buying local materials is not an option. How can we compare these two approaches? So in that case, you would probably have to manually change the transport distance. So we could, for example, take the option one, where we take resources which have been compensated. So let's say we assume that these are made in Germany or something. And then if we have our other country where we're actually importing the data from, we could say, okay, we're actually importing these windows from Spain. So then we take the original emissions. I can maybe cover this also a bit more in session 6, by the way. And then, of course, we have more transport emissions because we have to fly it in. That is actually very common for Middle Eastern, where they just cannot produce everything locally, so they have to fly stuff in. Singapore is also a really good example of that. An anonymous attendee asked, when we are changing some materials to greener side, what permissions we need, or are we providing some options? I mean, you can just make some choices yourself, like, doesn't really matter. If you're doing this, of course, from an actual product, you should probably take materials which are actually, or which would realistically be available to you. How are you changing the units? So a lot of materials actually allow you to change different type of units. So if you're in the software, you can just select different units and it will automatically convert them. Kevin asks, not sure if this question has already been covered, but what do we do if there's no EPD present for a particular material or product? Is there a default EPD? So in those cases, you could use a generic EPD. So a normal type 3 manufacturer specific EPD is a product that the manufacturer has recorded the emissions for. But of course, there's also generic materials, which, for example, cover a typical concrete for Finland or a typical plastic profile for Europe. So you could use those if you want to do a comparison. Mark asked if we have reused materials according to the A1. You mentioned it will remove the A1 to A3 and A5. However, in the A1 amendment, biogenic carbon is not accounted for separately. So wouldn't that mean a high C1 to C4 emissions when using recycled wood, seeing that the wood still uses a lot of carbon? Technically, yes, but of course, you would also have the benefits from incinerating this wood. So you also have benefits in the D phase. So you still have some good stuff from that. Subharna asked, are there any energy efficient building called as resource efficient? Yeah, they could be called resource efficient because they might have to use less energy or less fuel to heat the building, to cool the building and whatnot. For reclaimed recycled materials, is the cut-off allocation always used, or is there a way to consider other allocation methods? Currently, we just have one method there. There's a couple of EPDs which actually represent recycled products, so then they, of course, use a different methodology. But we have kind of simplified it to make it easier that you can actually account for any material to be reused. What was the square meter of the building in the bill of quality? 7,500 square meters. So 7500. You'll also be able to find it in the slide. Maybe I'll put it to this one. Or 7,000, my bad. Did I change it? Okay. An anonymous question asks, how many credits do you need for certification? Depends completely on the certification and what you want to achieve. Subarna asks if there a way to optimize emissions and costs simultaneously. Definitely. If you do a lifecycle costing analysis, like next to your lifecycle assessment analysis, you can indeed. Shadwa asks, when we are speaking about GHG emissions, are we speaking about the global warming potential? In this case, I was mostly talking about global warming potential, yes. But there are, of course, other greenhouse gas emissions you can also calculate. Tomaj asks, hi, Stephen, have the level of adaptability and material circularity in buildings been standardized yet? For example, in BREEAM? Not really. Circularity is something which is really upcoming still. There is some frameworks there, but it is not like included really in any certification yet. I assume it will be in the near future. Hannah asks, what are the criteria for choosing a baseline building to assess durability of the building? Well, the baseline should always be typical. Like, as I said before, especially important in LEED. So we have to use materials which are typical for construction, which means that if I'm building an office in Helsinki, and typically this is a concrete building, I will use a concrete for my baseline. But if I'm then wanting to do something more better, I want to reduce these emissions, I could choose for a wooden frame, a timber frame. So I would say typical stuff. Cannot really tell for any area what is typical, unfortunately. Like, you have to be a local expert on that. And I'm not the local expert on every country in the world. An anonymous question here is, if the optimization of the building life cycle has impact for less than 60 years, wait, if it's worthless, what are the best scenarios for refurbishment projects? I mean, if you want to really focus on the benefits of refurbishment, you can basically do a whole building LCA, which assumes that the building would be built new 60-year life cycle, and then assume in your second design, the existing part is already there and you're only adding some new refurbished materials. You'll easily see the benefits of refurbishment. I also recommend to check that article, which I showed a short link to earlier. What was that? This one, low carbon refurbishment. Check that out. Okay, and I asked, something is very strange. Changing some structural materials is very dangerous. Something we cannot do, but you do that so easily. I think we must organize architectural items. I mean, you are not always able to change the structure, depending on where you're building, of course, if you have certain safety regulations for natural disasters or whatnot. But changing the structural materials is one of those things you can get a lot of savings from. So if it's not possible, you have to look at other things like architectural items, yeah. An anonymous attendee asks, how significant does furniture decoration affect the LCA for buildings? Depends. Furniture LCA or interior LCA is not something that is done that quick or that often. In LEED, we have, of course, the IDC credits. We have also tools for interior design, but there are not a lot of data points for interior design yet. Like, probably we have the most data points from any other software in the world for interiors, but still, it can be quite big. In the United Kingdom, for example, they do ask you also to include interiors and fittings in, for example, the GLA assessments. It can be quite big, but I don't have too much knowledge on interior design, unfortunately. It's not really the topic of this this session. Oh. An anonymous attendee asked, does the parameter that input for doors, pipes, and any miscellaneous part of the building available for the input settings? Not really sure what you mean, but you don't have to use the filter settings if you search for stuff. You can also just search for keywords. So if you just want to search for doors or pipes or whatever you're looking for, you will find it by just typing it. Suganya asks how to model lime used in internal wall coating. The limestone is sourced locally made into lime putty. So of course, in the building LCA tool, you cannot do product LCA. So you cannot model the entire process of a material. But if you can find the raw materials, which you might be able to find, you can still model it in your internal wall coating. We definitely have lime. I'm just not sure if we have bio-based lime additives. What is the process for certification? Depends very much on your certification that you're trying to pursue. That's a question that we can probably talk about for another 5 hours. So maybe we'll discuss that in session 8 when we actually discuss certifications. Could you please tell us again which type forms is the best one to decrease CO2? From Kehan, I'm not really sure what you mean. If you check these slides later, or maybe we actually go to one link, this one. Does it open it? You can find what you can do for decreasing here as well at this link. I'll put it again there. Oh, I put it to the wrong, sorry. There you go. Anonymous question, does the software help you plan for roof materials that are better for solar installation? It does not. You have to really plan that yourself. There are some constructions for solar panels, but they don't tell you like what are the best materials to mount solar panels on or anything like this. Tatiana asks, LCA can be deeply connected to the renovation effort. Shouldn't it be possible to consider the built environment as maintained and consider whatever is new in the renovation projects? Yeah, you could. The only kind of issue is there if you have materials which are already on place and they do have to be maintained over the life cycle of the building, let's say the next 60 years of the function of the building, they will also have emissions. So not including that completely is maybe not really the way to go. Does the software and EPD look for materials or pillar foundation using less concrete? There are EPDs for piling you can find. Usually these are precast piles, but if you don't have those, you can always calculate it based on the quantities of concrete and reinforcement that go there. 100% plastic recycled products that don't have EPDs, does it need to be marked as reused? Yeah, you could probably do that. I'm not that familiar with this specific precious plastic initiative, but if you know that they are available locally, you can of course just assume that it's locally produced and you have lower transportation. Considering the 10 design strategies, how exactly has the Bloomberg office in London achieved the most sustainable office in the world? I'm pretty sure they use BREEAM, if I'm not mistaken. And a BREEAM credit is not just building LCA. It is many, many other things. For a building to be sustainable, you have to do building LCA, but you also have to consider the energy, the water, the reachability, waste management, and all these kind of things. If it was LEED, it still is the same story. Like LEED is not just building LCA, it's a variety of different type of credits that all help each other. Anonymous question here, can optimizing the shape and placement of the building, implementing strategies for by integrated in the software by any method? Well, passive energy saving materials or whatnot would of course reduce the operational emissions, but that would kind of be energy management, which is not something you can do with our software, but you could do that with IES or EDA ICE or TAS or something like this. Can the software include assessment of outdoor solar parking, simple sunshade covers? Yeah, of course. If you know what kind of materials you need, you can probably find them in the database. Question here is, what average percentage of insulation affects total emissions? Ooh, let's see, what do I have in my assessment here? The top 10, we have the first insulation, EPS, 7.8% of total. So it can be like 10%. Of course, also very much depends on what type of insulation, but we also have some glass wool, which is also insulation. What is the time limit for the multiple choice exam? It will be 60 minutes. Basically, once I give you guys the link, when the exam happens, you have 60 minutes for it. There's not a timer for each session. My exam software is not that fancy. An anonymous question is, do you have trained consultants placed in regions like San Diego? We unfortunately don't have that much North American staff right now, so we have only our excellent CS specialist Samantha right now, but she's in Halifax, not in America. Like we are, of course, from origin a Finnish company. We do have staff with 25 different nationalities all over the world, but not that much in North America as of today. Luciana then asked, how can we determine compliance with science-based aligned net zero decarbonization targets? For example, a very high baseline reduced by, let's say, 30% might still be high in emissions and not be considered green. That is true. Depends on what you're trying to calculate, of course. Like if we really want to be net zero, you probably have to offset the emissions also. So then you might have to invest in forests or anything like this. Like you cannot always build completely net zero carbon. Like passive house is possible, but I have never heard of an office doing, for example, that completely. So depends. There is some articles on our website also about net zero, which you can check out. I think we then have pretty much answered all the questions, 127 questions. Thank you very much. You can send me a message on LinkedIn, Abdullah, and we can see if we can do something. Thank you all very much for joining. I will have to make sure that the session is, of course, processed again, and I'll make sure that our amazing marketing team sends you the session and also the bill of materials and the slides, just in case. Right. See you guys tomorrow. Tomorrow will be the session by our CEO, Panu Pasanen, who will be talking about materials, but I'll be on the panelist thing there. So I will at least talk to you guys on Monday again. So cheers. Oh, wait, I had to actually make a selfie for our marketing department. Give me 1 second. So selfie. All righty. Bye-bye.